Okay, so in this session, we have to learn how to convert real voltage source to real current source and real current source into the real voltage source is there. As we know that all the basic concepts related to real voltage source and the real current source. Once again, I will try to repeat that part. Real voltage source. When I say that real voltage source, so what you can remember, it has its a finite value of internal resistance, and that internal resistance is always shown in a series with that voltage source. So that my diagram should be like this. This is a point A and B. This is a voltage source and this is an internal resistance. Is it right? And when we say about real current source, so what you can remember about that real current source? This real current source is also having the finite value of internal resistance, and that can be represented in parallel with that current source. That's why my diagram for the real current source should be like this. These are the 2 points A and B. This is a current source I, and here I can write it down, it's a internal resistance. This is the major difference between them is there. Now, sometimes while simplifying the circuit diagram, it is necessary to convert one source, one form of source into another form. Means the real voltage source into real current source and the real current source into the real voltage source. It depends upon the circuit. What I say that sometimes while simplifying the circuit diagram, it is necessary to convert one form of source into the another form of source is there. And for that, we must have the knowledge about how one can convert one source into the another source is there. So let's we start with the first part, real voltage source into the real current source. So as you know that this is the circuit diagram of a real voltage source, you can see that here, this is the ideal voltage source and one internal resistance, it is placed in series with that voltage source. That's why we say that it is the real voltage source. And when we say about the real current source, so definitely this is a current source, this is the internal resistance which is connected in parallel, and these are the two terminals here. So when we want to convert this real voltage source into the real current source, the procedure is like that. आता ज्यावेळेस आपल्याला रियल व्होल्टेज सोर्स हा रियल करंट सोर्स मध्ये कन्वर्ट करायचा असेल तर त्यावेळेस आपल्याला स्ट्रक्चर तर माहित आहे की एक करंट सोर्स असला पाहिजे आणि एक इंटरनल रेजिस्टन्स असला पाहिजे आणि दोन टर्मिनल ए आणि बी. मग आता प्रश्न असा येतो की इंटरनल रेजिस्टन्स किती असला पाहिजे करंट सोर्सचा आणि करंट सोर्सची व्हॅल्यू किती असली पाहिजे. म्हणजे ह्या दोन गोष्टीबद्दल प्रश्न उपस्थित होतो की जर आपल्याकडे रियल व्होल्टेज सोर्स आहे त्याचं कन्व्हर्जन रियल करंट सोर्स मध्ये करत असताना इंटरनल रेजिस्टन्स किती घ्यायचा किंवा करंट सोर्सची व्हॅल्यू किती घ्यायची आणि त्याच्यासाठी प्रोसिजर इथे दिलेली आहे. स्टेप्स 1, calculate the value of current source by applying the Ohm's law, nothing but that Ohm's law. If I want to calculate that value of this current source I, and what you know that the voltage source and its internal resistance, so just apply that Ohm's law, that is nothing but V divided by R internal, and this is the value of a current source is there. And second step is that internal resistance for current source is the same as a voltage source. Now what value of internal resistance of voltage source is present, same value of internal resistance is for the real current source, but the only one difference is that you need to connect in a parallel. You need to connect in a parallel. And the third step is connect the load resistance between the two terminal A and B. मग हा तिथून पुढचा पार्ट झाला. आपण आतापर्यंत फक्त रियल व्होल्टेज सोर्स इंटू रियल करंट सोर्स बघितला. सगळ्यांच्या लक्षात आलं का? एकदम सिंपल प्रोसिजर आहे. तुमच्याकडे व्होल्टेज सोर्सची व्हॅल्यू माहित आहे, इंटरनल रेजिस्टन्स माहित आहे आणि त्याच्यावरून जर तुम्हाला करंट सोर्स करायचा असेल तर फक्त ओम्स लॉ अप्लाय करायचा आहे करंट सोर्सची व्हॅल्यू कॅल्क्युलेट करण्यासाठी and that is nothing but I is equal to V divided by internal resistance, and that internal resistance of a current source is the same as the internal resistance of voltage source. Simple procedure is that. Is it that clear? Yes or no?
Yes, sir.
Okay, let's we see that the actual process now. Okay, so this is the theoretical part. Now I will try to show that the mathematically how to convert that real voltage source into the real current source. One minute please. So this is a real voltage source having a voltage of V volt, and internal resistance is connected in series with it, and the terminal A and B. And we have to convert it into the real current source. When I say that real current source means definitely one current source along with one internal resistance connected in parallel is required. Now if you see that to calculate the value of I, we use that formula I is equal to V divided by internal resistance. And that internal resistance for the current source is the same as the voltage source is there. Now this is the example. This is the example. Now this is, if you see that here, this one part, we call it a real voltage source. Why I say that it's a real voltage source? Because this is a value of voltage and this 2 ohm, which is connected in series. So we can consider that this is the internal resistance. And these are the two terminals A and B, and here one load resistance is connected across the A and B is there. And now we have to convert it into the real current source. The simple thing is that first we have to calculate that the value of current source. Now we know that current source means what? This is a one current source having a value of I, is it right? And one internal resistance, it must be connected in parallel with that current source, and these are the two terminals A and B, is it right? This is the internal resistance. Now the load resistance connected between the point A and B, it's the same, is it right? This is nothing but 10 ohm. But just we have to calculate that what is the value of I and that internal resistance. So we know that how to calculate that value of I, that I must be calculated by using the formula V divided by internal resistance. Now what is that value of V? It's a 10. Divided by internal resistance, it's a 2. So that I becomes 5 ampere. So this is I, which is equal to 5 ampere. And this is the internal resistance, which is same as the internal resistance of a voltage source. It's a 2 ohm. Is it that clear?
Yes, sir.
Okay. Now you just let me remove that my write up part here and then check it here. One minute. Okay, so now that the internal resistance of the current source is a 2 ohm, and that I is equal to V divided by internal resistance 10 divided by 2, which is equal to 5, and this 10 ohm load resistance is as it is, no doubt about it. Okay, so this is the main procedure here. Get it my point? Yes or no?
Yes, sir.
Okay, now let me prove these things again. Let me take that one slide so that I can prove it. 10 to 10. Okay. So here, if I consider, all of you please have attention here so that your concepts will be clear. Oh, let me Here I consider that one voltage source, I think it becomes 10 volt, one internal resistance, it becomes 2 ohm. These are the two terminals. I say that A, and this one is a B, and I think a 10 ohm resistance is connected in between the terminal A and B. Now we will do that analysis of this real voltage source. Can you calculate the total resistance of this circuit diagram? How these 2 and this 10 are connected?
Series.
Series.
So I say that here 2 plus 10, which is equal to 20 ohm. Apply that Ohm's law. V is equal to I into R total. V is a 10, I into 12. So that I, it becomes 10 divided by 12. So that I is equal to 0 0.2.
0.833.
833. 834, I say that. Okay, this is the value of I. Now we know that when the current I, same value of current, it flows through the both the resistance, means a current flowing through this 10 ohm resistance is 0.833, or I say that 834 ampere. Once you know the current flowing through this 10 ohm resistance, can you calculate that voltage across this 10 ohm resistance? If I consider that this voltage is a V1 and I want to calculate that V1 is equal to I into 10. So that I, it becomes 0.834 multiplied by 10. So that V1 is equal to 8.34. Okay. Is it that clear? Okay. Now we have to convert this real voltage source into real current source. How to convert it? You know that procedure. Consider that one current source. It's A terminal, positive terminal. This one is the B terminal, negative terminal. That value is I, is it right? And one internal resistance, is it right? So here I say that internal resistance. So can I say that here that this internal resistance of current source is a 2 ohm here? Yes? Yes or no?
Yes, sir.
And now that I value, we can calculate by using the formula V divided by internal resistance. Now what is that voltage? It's a 10 divided by 2, which is equal to 5 ampere. Now here I becomes 5 ampere. And now the resistance, load resistance is same as it is, that is nothing but 10. Now give me that this 2 ohm and this 10 ohm in the real current source, how they are connected?
Parallel.
So here let me assume that this is a current I1 and this is a current I2, and you know that the total current. Can you use that current divider formula and can you calculate that I2? I2 is equal to total current into opposite resistor divided by sum of the two resistance, means 2 plus 10. लक्षात आहे का फॉर्म्युला सगळ्यांच्या?
Yes, sir.
Which is
Yes, sir.
equal to 5 into 2 divided by 12, which is equal to 10 divided by 12. Is it there? आलं का बघा किती आला करंट? 0.834 एम्पियर. म्हणजे आपण व्होल्टेज सोर्स करंट सोर्स मध्ये कन्व्हर्जन केलं तरी त्या 10 ओहम मधून फ्लो होणारा करंट हा इथं I2 म्हणलेला आहे मी. नोटेशन काही असू द्या, परंतु त्याची व्हॅल्यू सेम आहे. गेट इट माय पॉइंट? या रियल व्होल्टेज सोर्स मध्ये 10 ओहम मधून फ्लो होणारा करंट हा 0.834 होता. आता आपण रियल व्होल्टेज सोर्स रियल करंट सोर्स मध्ये कन्व्हर्जन केलं तरी देखील 10 ओहम मधून फ्लो होणारा करंट सेमच आहे. दॅट इज नथिंग बट द कन्व्हर्जन रियल व्होल्टेज सोर्स इनटू द रियल करंट सोर्स. आता करंट सेम आहे म्हणजे त्याच्या अक्रॉसचं व्होल्टेज पण सेमच असणार. अप्लाय ओहम्स लॉ अँड ट्राय टू कॅल्क्युलेट दॅट व्होल्टेज. डेफिनेटली that voltage is same. It's a 8.34 ohm. Get it my point? लक्षात आला concept?
Yes, sir.
Okay. So all of you, please take a note of these things. Your title should be real voltage source to real current source, and then note down this one slide. Is it over? So right now we discussed that how to convert the real voltage source into real current source. Now exactly reverse also we have to discuss. That is nothing but how to convert real current source into the real voltage source. Exactly reverse. May I take that next point?
Yes, sir.
Okay. That example is not necessary. Once the concept is clear, you can take your own example and you can try to solve it. No doubt about it. Okay. Now, make the title real current source to real voltage source. Make the title real current source to real voltage source. And then concentrate here. Okay. Now please concentrate. Don't draw the diagram. I will give the time to write and draw these things. So now we have to learn that how to convert that real current source to real voltage source. Now if you see that this is the real current source, you can see that the current source, it's an internal resistance which is connected in parallel. And these are the two terminals of a current source. And we have to convert it into voltage source. It means that आता ज्या अर्थी आपण करंट सोर्सचं व्होल्टेज सोर्समध्ये कन्वर्जन करतोय त्या अर्थी आपल्याला करंट सोर्सचे पॅरामीटर्स माहित आहेत. दिस इज द नोन टर्म्स अँड वी हॅव टू कन्वर्ट इट इन टू. म्हणजे आपल्याला करंट सोर्सची व्हॅल्यू माहित आहे, इंटरनल रेजिस्टन्स माहित आहे, अँड नाव वी हॅव टू कन्वर्ट इट इन टू व्होल्टेज सोर्स. आता ज्या अर्थी आपल्याला व्होल्टेज सोर्समध्ये कन्वर्जन करायचं आहे याचा अर्थ एक व्होल्टेज सोर्स असला पाहिजे आणि त्याच्या सेरीजमध्ये त्याचा इंटरनल रेजिस्टन्स असला पाहिजे. अँड दीज आर द टू टर्मिनल्स ए अँड बी. Again, the procedure is remain same. How to find out the internal resistance and how to find out the value of voltage. Again, the procedure is remain same. Step number one, calculate the value of voltage source by the formula. Again, Ohm's law. V is equal to current source value. We know that is nothing but I into its internal resistance. So I say that R internal. Ohm's law. So we will get the value of voltage source. And the step second is that we know that the internal resistance of a voltage source is the same as the internal resistance of a current source. Exactly reverse. Is it that clear? And then the two terminal, the load, whatever the load is connected in between the two terminal A and B, this load is as it is. So simple. Is it right? So now see that, what is that? This is an ideal current source. Now we have to convert it into real voltage source, real current source and the real voltage source. So this is the formula to calculate the value of a voltage source, that I into, actually this not a R, actually this R is nothing but what? Internal resistance. Is it right? and the internal resistance is same as it is. Okay. Now see that example. If here I consider that this is an real current source, and a 10 ohm resistance is connected between the point A and B. And now we have to convert it into real voltage source. When I say that real voltage source, so definitely one voltage source, it's a terminal A, and one resistance, internal resistance, is in series with that voltage source. Now the thing is that how to calculate that the value of this voltage source. So simple, apply Ohm's law, I into internal resistance. Now what is that value of I? Is a 5 into internal resistance is 2. So that value of voltage source is a 10 volt. And internal resistance is a remain same, which is nothing but 2 ohm. This is the procedure. And then what the load resistance is connected between the terminal A and B for the current source, same load resistance you can connect in between the same 2 points between A and B. Is it that clear? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then is it necessary to solve that example? Because we have already solved that example based on it. Okay. Otherwise, let me try to solve that example. Okay. So forget about the title, but I can consider uh, voltage source to current source. Which one we discussed? Current source to voltage source. Okay, let me consider that one current source having now different value. Let me consider here. It is I consider that 5 ampere, or okay, and this is a one resistance, we call it the internal resistance, is 3 ohm, and these are the two terminals A and B. And here we consider that 120 ohm resistance is connected between A and B. Let's we try to do that analysis of these things. So suppose I consider that this is a I1 and this one is a I2. Is it right? So how to calculate that I2 here? I2 is equal to total current into opposite resistor divided by sum of the two resistances. Now the total current is 5 multiplied by 3 divided by 23. So can you give me that I2 current here? Yes, please.
0.652.
0.652.
652 ampere. Now, once you know that current flowing through this 20 ohm resistance, you can calculate its voltage. Suppose, let me consider that that voltage is VL, load voltage. So I can calculate VL is equal to I2 multiplied by 20 ohms law, which is equal to 0.65. 65 काय सांगितलं होतं?
2.
2.
2.
हाँ ये
2,
2
sir.
है बोला 652 multiplied by 20, so that VL is
13.04.
ah
13.04.
13.04 volt. Okay, now see here, we will try to convert it into equivalent voltage source. And when I say that voltage source, so definitely I have to consider that one voltage source along with its internal resistance, and these are the two terminals. I say that A, and this is another terminal, I say that B. Now we have to calculate its value, means voltage value. And now that internal resistance, may I consider here that internal resistance is same, that is nothing but it's a 3 ohm, and a load resistance is same as it is in between the terminal A and B is there. But only the thing is that we have to calculate that value of voltage and that can be calculated by using that Ohm's law, I into internal resistance. Now what is that value of I? It's a 5. Internal resistance, it's a 3. So it should be 15 volts. So here voltage is equal to 15 volts. Now we will do that analysis here. As you know that now this 3 ohm and this 20 ohm, they are connected in series. So the total resistance is 20 plus 3, which is equal to 23 ohm. It's right. Then we will try to calculate that current. So we apply that Ohm's law. V is equal to I into R total. Total voltage is 15 is equal to I into R total is 23. So that I is equal to 15 divided by 23. So definitely it's the same answer it comes. That is nothing but 0.652 ampere. So what the current it will flow through this 20 ohm resistance? That is nothing but 0.652 ampere in this case. And what the current it flows through this 20 ohm resistance in this case? That is nothing but 0.652. Is it the same?
Yes, sir.
Yes.
Absolutely. It should be same. It must be same. Is it right? And once the current flowing through this resistance, if it is same, by default that voltage across it, it's also same is there, and you will get it the 13.0. Get it my point? Is it that clear? Yes or no?
Yes,
Yes.
sir.
Yes, sir.
Then note down these things. Is it over?
Yes, sir.
So let me go to that next slide. Okay, so this is about how to convert that one form of source into another form of source. Is it right? Another one small concept it remains, that is nothing but the open circuit and the short circuit. And once these concepts will be over, then we will start that very important concept, and that is nothing but the Kirchhoff's laws. And this one is the last point of this topic. Is there? Is it right? So definitely, in the fresh mood, we will try to start that the point open circuit and the short circuit. So today we will stop here. Okay. Thank you.